Okay, here's how we can deal with radicals and how they're involved with solving equations. So here's the way I want to think about this. Let's say we're solving an equation that looks kind of like this one, where you have uh, a 1/5 in the exponent. How do you get rid of that exponent? And how do you get rid of exponents in general by doing the same operation to both sides of an equation? So for example, let's say you have x to the 1/5 power, and you want to just do something to that to turn it into x. Uh, or what if you have something to the power 7, and you want to do something to just get rid of that 7? Well, what you can do is use this fact. If you take x to the 1/5 and just raise both sides of the equation you're dealing with to the power 5, then what you get is x to the power 1/5 times 5, but then 1/5 times 5 is just 1, so this is just x to the 1. So that's what you want to do. Raise both sides to the power that is the reciprocal of that exponent. Same idea here. If you have this thing and this 3b minus 3b minus 2 to the power 7, and you want to do something to that to just get rid of the exponent 7, what you can do is just take the whole thing and raise it to the power 1/7. And those exponents will multiply, and you'll just get 3b minus 2 to the power 1, which is what you want. And that is how you can get rid of exponents, by raising both sides to the reciprocal power. Whatever it takes to get rid of that 7 and get a result of 1 in the exponent. So let's see here. The first thing I'm going to show you is a really common mistake with this. If you have this example and you raise both sides to the power 5, let's look at what will happen if we have this 4 times the quantity x plus 2 to the power 1/5. You can raise both sides to the power 5 here, but what that will look like is like this. You have to do the whole thing to the power 5, and then this whole thing to the power 5 here. And that's okay as long as you remember to do the 4 to the power 5 here as well, because there's really two different factors here. There's the 4 and then this other thing, and both of those need to be raised to the power 5. And if you do this, you're going to get a really huge number, 4 to the power 5, which I don't even know what that is. It's huge. And then 12 to the power 5 is even bigger, and I don't want to deal with these huge numbers. So instead of doing it that way, let's just isolate the exponential part first. So that means divide both sides by 4. And that will cancel that out first. So you'll just get, as your first step, x plus 2 to the power 1/5. And then 12 divided by 4 is 3. And then that now, if you just raise that to the power 5, you only have one factor over here, and you just end up getting x plus 2 to the power 1, also known as x plus 2. And of course, I need to do it on the other side as well. And 3 to the power 5 is 243. So this just gives you x plus 2 equals 243. You can subtract 2 from both sides and get x equals 241. And it's always a good idea to check this by plugging it into the original equation. So to check this one, I'm going to take this original thing, 4 times the quantity x plus 2 to the 1/5 power, and plug in 241 into that. 4 times 241 plus 2 to the power 1/5, and we get 12. Good, so that really checks. next, let's look at one that's a little bit more complicated. If we have an equation here with like 5 different variables in it, and we want to solve it for one of the variables in terms of the other ones, that means I want to get p equals, then first what we need to do is get rid of that 4th root. And just like before, we could write it as to the power 1/4 if you want. It's the same thing, but you don't really have to do the step. That's the same thing as to the power 1/4. But either way, it doesn't matter, because the first thing we're going to do to both sides is raise both sides to the power 4. It cancels out with the exponent 1/4 when you multiply, just like a 4th root to the power 4 cancels out the same way. So we're going to do this side to the power 4, and so we're going to get a result r to the power 4 equals all of that stuff without the exponent, because that all canceled out. Now I want to get the p by itself. I always like to do something like this when there's fractions involved and I want to get rid of the fractions. I always think it's a good idea to multiply both sides by the denominators, like so. That will give you, over here on the right side, it just cancels out, so you get 8LVF, and over here we got r to the 4th times pi times p. And now if the goal is to get that p all by itself on one side, all we need to do is divide both sides by everything else to cancel out that multiplication by that stuff. And that gives you a formula that looks like p equals that whole thing, 8LVF over r to the 4th times pi. And that's what the answer there should look like. And that's that. Now with for next, you've got an exercise to try on your own. This one should go pretty similarly to the ones I just did. And I should say something, if you're having trouble with these exercises, if you look at this and you say, oh my gosh, I have no idea how to do this, there's a good chance that you just went through the rest of the video a little bit too fast. Remember, I do these videos at kind of the fastest possible pace, with the idea that the student who already knows a lot of the stuff, I don't want to bore them out of their minds and keep them watching. So if you are not the fastest possible student, you should be hitting the pause button all the time. And if it's a 8-minute video, for example, it should be taking you like 15 minutes or 20 minutes just to get through the watching the video part. And then there's the exercise at the end to do. So you should be hitting the pause button again all the time, just to stop, write things down, read it again to make sure you understand it before I start talking about it. Because reading it and then listening to me and then trying to do stuff on your own, all of that at the same time is too much. So that's the nice thing about YouTube videos, is that you can pause it and make it go as slowly as you need to. So anyways, this exercise is for you. The answer's in the book for you to check. Please check it there, but do it on your own first here. It is really similar to the first example I did here. So I'll leave this one for you, and I'll see you in class.